Number 41 is negative cosine pi x plus c. 42 is negative cosine x to the fourth plus c. 43 is negative 1/2 cosine 2x plus c. 44 is 1/6 sine 6x plus c. 45 is negative 1 sine 1 over theta plus c. 46 is negative 1/2 cosine x squared plus c. Then we go to number 54, and you get negative 2 cotangent 1/2 x plus c. 65 is 0. 66 is 41,472. 67 is 10.7429. 68 is 1/3. 69 is 2. 70 is 1. 71 is 1/2. 72 is 3.618898. 75 is 1.299. And 76 is 0.819. All right. Come with questions over those for next time. So the next part is 2 new rules, and they help us find the area under the curve by not using the indefinite integral, which gives us the exact area, but by using trapezoids and then just some different crazy things. So at the beginning, you guys found the area under a curve by using rectangles. This is going to be trapezoids for the trapezoidal rule. So if you look at page 301, the trapezoidal rule is this crazy big long thing. And when you read it, you're like, yeah, what does that even mean? Well, let's walk through a problem, and we'll try to make sense of it. So, what the trapezoidal rule says is that you can find the area from A to B by doing this lovely little thing. So it has B minus A over 2N out in front on page 301. And so B is your top number. So we're going to go 2 minus A, which is 0. A is your bottom number. And then 2 times N. N in this case is 4. And so when we do that, we then have to take, it has lots of weird things inside there. It has f of x of 0 plus 2 times f of x of 1, and so on and so forth. So it looks really weird, but what we're going to do is plug in our starting value. So we're going to plug in 0 to this equation. And when you plug 0 in, you get 0. That's your first value. The second value is, if we split this into 4 boxes, or 4 trapezoids, it's going to make each of their widths 0.5. So the next value you're going to plug in is 0.5. The one after that would be 1. The one after that would be 1.5. And then you stop at 2. So if you see the pattern, it's like our upper and lower sums. You just keep putting in values. So we're going to put in 0.5, and when we put in 0.5, we get 0.25. Well, our formula says you have to take 2 times that. So we're going to take 2 times that value. Plus, when you put in 1, you get 1. So we're going to take 2 times 1. It says we have to take 2 times that as well. When you put in 1.5, you get 2.25. And we have to take that times 2. And then when you put in 2, you get 4. And that last number in the first number do not get multiplied by the 2. It's just the middle terms that get multiplied by the 2. So what we're going to do is we're going to evaluate this, and it's going to give us the area. So 2 minus 0 is 2 over 8 is 1/4. So I'm going to have to go ahead and simplify that. All of that I'm going to type in. So 0 plus 2 times 0.25 plus 2 plus 2.25 times 2 plus 4, and I get 11. So I'm going to take 11 times 1/4, and I get 2 and 0.75 units squared would be my answer by using the trapezoidal rule. So let's try another one. So on this one, N is still 4, the B and the A is the same, B is different. So we're going to go 1 minus 0 over 2 times N, which is 4, Our starting value is 0. Our next value is dependent upon the n and our width here of how far we're going from x to what. So 0 to 1, and we want to split it into 4 units, so we're going to go 0.25, 0.5, 0.75, and 1. So we're going to put in 0, and when we do, we get 1 plus, put in 0.25, and when you put in 0.25, you get 1.03125. Then put in 0.5, and when you put in 0.5, you get 1.125, and put in 0.75, and when you put in 0.75, you get 1.28125, and when you put in 1, you get 1.5. So what we're going to do is we're going to add all of that together inside. So 1 times 2, 1. So I'll let you guys do that. You might beat me done. That's your goal. Except for I'm typing in the wrong numbers. $9.375 is what I got there. So let me make sure I typed everything in correctly. Times 2, 2, 2. Alright, so I got that, and I'm going to take it times 1/8. And I get 1.171875 units squared as my area. So that's the trapezoidal rule. Simpson's rule is on page 303, and it looks very similar to the trapezoidal rule. Here is Simpson's rule. Notice it has b minus a, and then on the bottom it has 3n, and it's multiplying by 4 and 2 and 4, so it switches. So, for the most part, everything stays the same. So we're still going to do b minus a. So we're going to go 2 minus 0 over 3 times n. So that's a new thing, the 3, not the 2. All right, you're still going to start at 0. And then you're going to break it apart just like you did before. So we're going to go 0.5, 1, 1.5, and 2. Now on this one, when you put in 0, you get 0. Plus, for the second value, you take it times 4. For the next value, you take it times 2. And for the next value, you take it times 4, and so on and so forth. The first and the last terms, however, do not get multiplied by anything. So if I put in 0.5, I get 0.25. If I put in 1, I get 1. 1.5 is 2.25, and 2 squared is 4. So I simply just type that all into my calculator again. So 4 times 0.25 plus 2 plus 4 times 2.25 plus 4 is 16. And out in front, we said we would have 2 over 12, which is 1/6. So if I take 16 times 1/6, I get 2.67, or 2 2/3 units squared. So if we go back and look at our first example, when we did it with the trapezoidal rule, we got 2.75. And now when we do Simpson's rule, we get 2 2/3. So they're a little bit different. To find out which one's closer, you would actually do the antiderivative and plug in your values and see. So let's try one more with Simpson's rule. So if we try this one with Simpson's rule, we're going to have b minus a over 3 times n. We're going to start at 0. We're going from 0 to 1, and we want 4 spots. So we go 0.25, 0.5, 0.75, and 1. So our first value, when you plug in 0, you get 1, plus 4 times, when you put in 0.25, you get, and you should have this from the last slide, 1.03125, plus This time we're going to take 2 times whatever we get when we put in 0.5. And you get 1.125. Plus 4 times whatever you get when you put in 0.75. 1.28125. And then when you put in 1, you get 1.5. And we don't have to multiply the first one or the last one by anything. So what we are going to do is we are going to add those together and see what we get. So I'm just going to arrow up and go back and change what things need to be multiplied by rather than retyping all those crazy decimals in. And when I do, I get 14. So we're going to take 14 times 1/12. And so you get 1.16 or 1 1/16. So you can write it as 1 1/16 or 1.167 units squared. And if we go back and look at that last example, it gave us 1.17. So these ones are pretty close. And that is it for Simpsons and trapezoidal roll. Couple of questions for next time.